Station 51, engine 27, engine 32, truck 105.
You're listening to The Fire Break with Steve Wolf. Welcome back to The Fire Break. I'm Steve Wolf. As you know, The Fire Break is sponsored by Team Wildfire, developing innovative technologies for wildfire control, containment, and suppression. You can't beat that, right? What else do you need? Except that once you've sprayed a bunch of water on the fire and the water has picked up all the contaminants in the fire, then what happens to the water and who deals with those contaminants? Well, Cydian Kauffman is here to discuss this with us. Welcome to The Fire Break, Cydian. How are you today?
I'm great. How are you, Steve?
I'm good, but I'm concerned about what happens to all this toxic water that runs off from wildfires or from battery fires or structure fires. Really, I mean, when we contaminate water in quantities beyond that which can be captured, if we even try to capture it. So, what happens to all those contaminants, and how can we reduce that?
Yeah, they follow the hydrologic cycle, just like all the other possible contaminants in the world, which means that it's sitting on the ground and then it's washed away. At the site, it's usually washed away with a hose, but rain captures it, and that floods it down the road or down the hill, where it either drops into a sewer drain, which is a controlled source, or it drops into underground aquifers. So basically large basins, some of which can be the size of small seas that are underground that we then drill into to pull water up for people to drink. And if it's some of the stuff is small enough that it will actually retain its shape in the rain as it goes into the clouds and then drops down.
So when you say retain its shape, you mean that it remains in solution?
Yeah, it remains in solution. Okay. And that's not a lot. Luckily, the rain cycle does a ton to remove that. But then once the rain hits the ground again and pours across the ground, it captures more stuff again. So all that stuff is then captured in either a large basin called a reservoir. You know, as you're driving around your town, you may see tall fenced off areas. And if you go peer over that fence, you're going to see a giant...
You're going to see teenagers who snuck in there last night who are floating up in the morning.
Yeah, that's right.
Yes.
Yeah, exactly. So these basins are open and birds are pooping in them and all that stuff. But there's not really a better way to do that currently. And they're just... If it's a really hot area, you might see that there's like little floating balls on top of the water, which is meant to prevent the sun from evaporating it too much. But for the most part, these basins, whether underground or above ground, are where we all drink our municipal water from. And if we're not drinking municipal water, we're drinking well water, which still comes from the ground.
Right.
If you're on a well, it's up to you to treat that water.
Well, actually, not just up to you, but within your ability to treat that water.
That's right. Yeah.
For most people, right, they live on a municipal system, and whatever the system puts out, that's what they're stuck drinking.
That's right. Yep. So in those situations, the water that's captured in that reservoir is processed at a treatment plant. And they go through this process usually first. Obviously, every treatment plant is kind of based on the water quality, but usually first they go through what's called flocculation, which is where they add a chemical to the water to grab all the stuff that's in solution, pull it out of solution, and have it float to the surface or the bottom, where it's skimmed by big robots, so to speak, machines that have gotten pretty clever these days. And then after that's captured a good amount. They chlorinate, they dump chlorine in, and then they will generally run that through carbon. And which, form this takes, whether they do that first or second, it depends on the water. But running it through carbon is really a cool feature because carbon is incredible at capturing stuff that has been pulled out of solution. So stuff that is not bound to the water molecule, but is like more binding together, which happens with oxidization, which is what you're doing with chlorine. Carbon is great at capturing it because carbon has so much internal tunneling inside all the little pieces of carbon that it captures just a ton of contaminants, but not everything. And then after it gets through the carbon, and there may be other treatment mediums they use depending on the water, that's sent out to you. After all that, there is still stuff in your water, but they have to get it down to what's called the maximum contaminant level set by the EPA. So imagine
your water is as dirty as it's allowed to be.
That's right. Yeah. Imagine, if you will, a bunch of people sitting, scratching their head over how are we going to get this water down to a healthy level? And they try and try and try, and they do the math and they figure out, okay, it would cost like $10 billion to get this down to the health level. How about we set a legal level that is approachable? That way we don't have 80% of the municipalities in the country closing their doors. And that's why they have a different level for the health level and the legal level. The legal level is set based on the what is approachable and doable. It says that right on the EPA website. And then the health level is set based on the health, like what they actually want the goal to be. So the delta between the legal level and the health level is the homeowner's responsibility, which is why we have a company, is because of that. And so, yeah, fires particularly cause a lot of VOCs to exist in the water, as well as a lot of what's called forever chemicals, PFAS, which I'm sure you guys have spoken about quite a bit on your podcast.
Yes.
Yeah. So that's basically it. That's the cycle.
All right. So the fire comes through, generates both the natural byproducts of combustion, which ends up in the water the next time it rains, plus all the ammonium and phosphorus and other stuff, the iron oxide that is intentionally being put on the land for whatever reason.
Yeah.
Right. As if the long-term impact of these chemicals is going to be less than the long-term impact of a fire, which grows back 30 years later.
Right.
And maybe you decide to put your house someplace smarter. All right. Versus now we've contaminated the water supply with forever chemicals that are not so easy to get out.
Yeah.
Right. So, all right. So now you've got this VOC, PFAS, and heavy metals contaminated water runs into your municipal system. It's reduced to the level where any dirtier would be illegal, and then it's pumped into your house. So at that point, what are we doing? Are we filtering? Are we ROing? Like, how do we get back to healthy water to drink?
Yeah. So this is where we get into the science of small things.
Okay.
If you're being extreme about your health, which is a good thing, it's good to be extreme about your health, then you want to filter it at your house. I just don't want want everyone to come away from this believing that if they have a teeny tiny amount of something, that it's really, really scary. When we look at things in parts per billion, we're looking at a single dropper in an Olympic-sized swimming pool. That's how much. So if you were to have a swimming pool of pure water and then put a few droppers of a few different things in it, mix it up, and then go take a drink from that, that's not so bad, right?
For most things, right? Yeah.
Yeah. If you do that over and over and over and over and over and over again for 10, 20 years, well, then for 10 to 20 years, you are the filter.
Right.
Your body is the filter. So there is some logic to treating the water at your house. And for, what's going to be a $1,000 to $6,000 price tag generally, depending on how you want to approach it, that is not too bad. That's not too bad a price for something that you're trying to have help you filter stuff out of your body for, decades.
Or keep stuff from entering your body.
Yeah, that's what I mean. Yes, keep from entering your body for decades. So that's kind of the thought process. There are some people who have water that is dangerous. Those are very rare situations.
Well, are they really, though? I mean, they might be rare in urbanized North America, but for the other 99% of the world that lives drinking water out of the Mekong Delta,
you're right about that.
Like most people don't have access to healthy, fresh drinking water. No,
you're right about that. The percentage of people who have access to really pure drinking water is almost none. The amount of water there is on the planet versus drinking water, I think of all the water on the planet, less than 1%, I think it's in the decimals of a percentage, is actually drinkable. And so, yeah, that is very true. And access to that in the Mekong Delta or in the Amazon River Basin area in South America or, parts of Africa, and Africa is a giant place, obviously. So when I say parts of Africa, I mean parts. The effects of not having access to water is tremendous. It has massive social effects. People who don't have access to clean water have to travel hours to get it. That's women and children doing it. Gender equality in those areas is virtually impossible because of that. It's like it has a huge effect, for sure. Yeah.
Okay. So let's say I have the luxury of not starting with sewage water coming out of the local river that's used for everything from industrial applications to the neighborhood sewer system, or even if I do start with that, what are the processes that I can control?
Yeah.
Right.
We like to suggest testing. That way you can customize something. If you don't want to test, an under-counter RO is your go-to solution for most.
Or what about an over-counter RO? For a
an
portable
over-counter
situation.
or a point-of-use reverse osmosis. Yeah.
Okay.
So you get a reverse osmosis system that's a decent quality reverse osmosis system, and you drink all your water from that. You are getting 99% of anything that could be in your water. That being said, some small amounts of PFAS can get through if the PFAS amount starts large enough. Some arsenic can get through if it's not properly oxidized. I think it's barium in high enough amounts. So there's some stuff RO doesn't do, which is why we always suggest that you test. Also, if your chlorine level is too high, in your municipality, you will destroy the RO faster than the RO is rated for. And some municipalities have chlorine levels that high.
So can you start with, like a carbon filter for catching chemicals, then move to something that's catching your microplastics?
Yeah, every single
and
RO.
Then RO it?
Yeah, every RO will start with a carbon filter or it's not doing its job. They all will. But if you have 4 parts per million of chlorine coming through, you could wear down that carbon in 2 months, 3 months, and then the thing is rated for 6 months. So for 3 months, you're destroying your RO membrane. And then in 9 months to 1 year, you're not actually treating your water, but you think you are. So
what kind of a home testing kit can I use to know when my RO has stopped working?
Yeah, so there's a TDS meter that is basically going to be your go-to solution for checking your RO and seeing if it's properly functioning. And what you want to do is, run
TDS
the water.
stands for total dissolved solids.
That's right. Yeah, total dissolved solids. Yeah, and they're not expensive to get. You do need to wash them and clean them, otherwise they will become uncalibrated. But as long as you're, keeping up on what it specifies when you get the little meter to make sure that the the little electrodes inside it are not covered in TDS, dissolved
Okay.
solids, but dissolved solids that will make it so that the reading is off, then it's a good way to check. And what you do is when you get your reverse osmosis water for the first time, you run a little bit, dump the first glass, and then, test the TDS, and then do that every couple months, every month if you want to, because it's not hard to do, and just make sure that it's keeping up on it.
So what are the things? What are the things that are not dissolved solids, but are things that are in solution? Like, is chlorine a dissolved solid, or is that?
Yeah, it's not. Yeah.
Right. So would that even show in a TDS?
No, it wouldn't. Sugar wouldn't show. Chlorine. There's a ton of stuff that wouldn't actually show. Basically, all the TDS is doing is running a current through the water and checking conductivity.
Right.
So if it's not conductive, it's not going to show. It's not going to show bacteria. There's hundreds of things it won't show. So the chlorine test strips are pretty good for checking the chlorine level. I mean, there's better ways, but that for people who are doing it at home, that's the best you're going to get.
But if we're trying to get, but you said that like a 4 ppm chlorine would destroy your RO member, and if we're checking for TDS that doesn't check for chlorine, then how do I know whether I've got water that's safe to put through the RO?
Yep. So you're going to get a good test strip, and
like the one I would use in my pool, or is it something more sensitive than that?
It's a little more sensitive because your pool water, well, actually, the one that you use for a pool is fine, to tell you the truth. That would be fine. But the test strips have to be a range that goes, below 1 part per million up to 10 parts per million. So it would be ideally either one of those test strips that go to 0.5 to 5. 5 is probably fine, because if you hit off the chart with 5, you're like, okay, this is crazy.
Okay.
And then you're going to want to be pre-treating for the whole house for chlorine anyhow. Municipalities are not supposed to get down up to that level, but they do all the time, because with chlorine, it's incredibly hard to identify if you're the first in the line after the plant versus the last in the line. Your chlorine level is going to be much higher at the beginning than the end. Sometimes at the end of the line, people are getting bacteria buildup in their home because they don't have enough chlorine level. If that happens, they have to put more chlorine in up here or create another port downstream. Like, those are the only two options, and all that costs money. So
how does the chlorine come out of solution as it goes down the pipeline? Does it evaporate off, or what happens?
Well, that actually happens because, it's a trade-off. And chlorine comes out of solution because it does its job. It oxidizes. Okay. As soon as it oxidizes, it's no longer available to oxidize.
Right.
And it creates what's called chlorine byproducts, which are your dibromochloromethanes and chloroforms, haloacetic acids, trihalomethanes, all that stuff. Some of which can be in high enough amounts. Chlorine byproducts can be genuinely problematic for people's health. So these are all things that, not all of them. So half of them, good carbon filters will reduce, but some of them require what's called anionic resin to reduce it, because it becomes negatively charged, and is small enough carbon is not catching it. So. And that's where you're talking about your chloramines versus chlorine, which is an ammonia-chlorine mixture that can either happen naturally or is sometimes being dumped in directly because it is cheaper to kill stuff with that than with chlorine. So
okay. And are there bromine systems for water the way there are for pools and hot tubs?
Yeah, there are, for sure. Yeah, you can get, so this is where we get back to the discussion of how I like to do things.
Okay.
What I like to do is test. And if you really want to make sure your water is like perfect, you need to test. And like a doctor would, you identify everything that's in the water, and then you basically look at the math and science. You compare competing things, and then you design a system that's customized for that. and and
That's
that
based
can
on continuity of water quality, right? Where
yeah, and that can get really complex. Like
right.
some water is really easy. Okay, that's a softener, that's a carbon filter. It's easy, right? Some is like your pH is at 6.5, which means that chlorine's not going to work, but you have bacteria, so you have to raise the pH in order for the chlorine to even work. And as soon as you're chlorinating, your iron level suddenly becomes oxidized, turns from ferrous to ferric iron, which means it's orange and gross looking in color. So you're having to remove that too. It can get complex. Things can compete with each other, and that's where a lot of testing and a lot of like experience is the only way you're going to get to a result.
Okay. What about evaporative distillation?
Yeah.
Now, so
So
are there chemicals that are in our water that evaporate at a lower temperature than the water does that would then move over to the water vessel that you're condensing in?
yeah, so stuff. Yes, there is stuff that will travel through distillation. It is still one of the. It is not more used because it's really hard.
Okay.
It's a
Yeah,
hard way to treat water. It is one of the most energy intensive ways
for
to
sure.
yeah to remove contaminants from water. And yes, there are tiny microscopic little steam droplets that float up and then over and get captured. And yes, stuff can float in that microscopic steam droplets. You won't get down to like 18 milliQ water. You're not going to get to perfectly pure water that way, but pretty much you can drink that water. Like
Okay.
you can rely on the fact that that water is incredibly pure. So if you're distilling it, yes. That being said, if you have a ton of like forever chemicals prior to that, that could get through to a level that you don't want, because forever chemicals are looked at in parts per trillion for the health guidelines.
Okay.
Very small amounts are considered unsafe, and we have a ton of forever chemicals in our water currently.
I see. All right. Are there mechanical filters that remove PFAS?
Yeah, well, currently anionic resin is one of the better ways to remove PFAS, but it has a downside of being easily overwhelmable and of having a higher failure rate. So it's removing more when it works, has a higher failure rate. Reverse osmosis removes a ton, but pre-treatment is required if you have enough, and it's not removing all of it. Carbon is currently the go-to solution for PFAS in large volumes. And when all these municipalities in 2000, I think it's changed to 2031 with this current administration.
Okay.
In 2031, all of the municipalities around the country have to get below 4 parts per trillion of some of the PFAS.
Okay. So could the fires be generating their own filters in that, are we able to use the burned up trees as a carbon source for making filters?
Yes. I mean, any carbon will definitely work for sure. Yeah. But carbon itself, like when it's just burned off a tree, that does not filter things as well as when it's processed and catalyzed. So all that carbon is like stuffed full of stuff. So
Right.
all of the available filtration is used up
Okay.
currently when it's just been burnt. It needs to be processed and acid washed to get all those holes that are inside of it available. Like carbon is basically like take 1 gram of carbon. If you go down with a microscope and are able to look inside that and travel through those tunnels, there are so many tunnels in that if you were to spread the surface area of a single gram of carbon out, it would cover 3 tennis courts, which
Are
is
these grass tennis courts or composite tennis courts?
yeah, but that much size, yeah.
Wow, that's a lot.
Yeah, it's a lot of surface area. And so you can imagine that all that with a freshly burned like tree,
Yeah.
it's all those holes are taken up already.
Which
So
is good, I guess, because that's that much less that got released by the fire, right?
yeah, that's right. That's true.
It
And so you take
cleans up
that.
some of its own garbage.
Exactly. Yeah.
Okay.
Yeah. You acid wash that, it releases the carbon, and then you have carbon available for treating stuff.
I see. So, you talk about testing, and we said one of the limitations of that was the need for retesting because you might have inconsistent levels of chlorine, PFAS, microplastics, etc., which would require that you re-engineer your filtration system every time you get a new result. And then there's circumstances where, I think about my crew that's traveling on fires,
Hmm.
and the water's going to be different everywhere they go.
Yeah.
There's going to be stream water, pond water, municipal water from who knows how poor a quality source.
Yeah.
So I'm looking for, a system we can travel with, that whatever you put in it, you get clean water, you get healthy level water coming out the end, because, firefighters go through a lot of water. I mean, in their body, right? When they're
Yeah.
chugging down 6,000 calories a day of intense mountainside work, they need
Yeah.
to drink a lot of water. So if there's bad crap in that water, they're getting a lot of bad crap.
Yeah. So you're talking about for drinking water. That makes a lot of sense.
Well, yeah, I'll come back to drinking water, but you talked about whole house systems. To what degree are we absorbing bad chemicals through our skin when we bathe or shower?
Yeah, there is not enough research on that.
Okay.
The preliminary research, I study arsenic a lot, so let's take arsenic. Preliminary research is indicating that 1% is getting into your body through your skin of arsenic.
Okay.
So
So
yeah,
if you start at 1 ppm, you're ending up at
yeah,
1 part per 100 million.
yeah, exactly. Yeah, exactly.
Okay.
0.01 is what you would be at.
So we'll go back to drinking water then, because I think that's probably what most people, most
Yeah.
people probably don't do a whole house system, but they do something at the water that they drink.
Well, let's talk about PFAS for a second, because
Okay.
it's interesting. It's interesting, like, when I say not enough research has been done, I can't exaggerate that enough. There's 100,000 theoretical types of PFAS. There's 14,000 that we've roughly identified. We've tested for health six,
Wow.
and every single one of them have shown to have health problems. So, I mean, we don't know near enough, but we do know that out of those six, and then some theoretical others that some people are like have an idea of, and they've done some preliminary tests, those can have skin effects. And very near us, we've got a municipality with a ton of PFAS in the water, and those clients are calling me up saying they're losing their hair from their water. And you can't.
I could be one of them.
You could be one of. You might have. And I don't know if they are losing their hair from that, right?
Right.
I can't tell them they're not. I can't take their word for it. I did research immediately because I had never heard of that before. And some studies have shown that some PFAS might actually have that effect. So that's a direct effect from showering on hair loss, which is pretty tremendous if you think about it.
How do you know it's from an external source versus water they consumed?
We don't know. Yeah, it's either they're drinking it and it's causing hair loss, or it's they're bathing it and they're causing hair loss, and we don't know. Like there is just so much we don't know about it, and I guess drinking it's maybe a little more likely, but I really don't know. I don't know enough about hair follicles and why hair falls out, and it's not my field. So
Right.
I mean, the customer's positive it's from showering, so I give them a whole home solution for PFAS. But but other customers, yeah, they could just do reverse osmosis.
Okay. I think a lot of people probably didn't know that PFAS was a class of chemicals and not a type of chemical.
Yeah.
Right. And so you said there's 100,000 different PFASs.
Yeah.
Um, is that, even if we haven't studied them each, do we know the names of those 100,000 chemicals?
No, we don't even know the names of all of them. No, we have not even gotten down that far. It is kind of it is a whole. We need to have faster testing for the parts per trillion and parts per quadrillion before we're going to be able to do that. Our
Okay.
parts per trillion, parts per quadrillion testing is incredibly slow right now. So
Okay.
we're just at the mercy of
Of the
reality
technology that we have.
until then,
Yeah.
yeah.
And
And
are all PFAS man-made, or they're naturally occurring?
all man-made,
All man-made.
100% man-made.
Okay. So the more research that came out about PFAS, the easier it would be to build a liability case
Yeah.
against manufacturers. So probably no one's going to be jumping in to do this research without opposition.
Right, exactly. Yeah. And yeah, I mean DuPont is pretty well protected by, case law that they have around they say, sure, we have these byproducts, but look at all the good we've done, and that's
That's right.
already been
Like, don't just focus on PFAS. Think of the good things that we've done, like Agent Orange.
exactly. Oh my god. Agent Orange, like you're bringing me back. But yeah, DuPont's got quite a history, right? But yeah, they that is already in case. There's too much case law protecting corporations from that kind of thing. It would have to be a pretty tremendous weight to push that over, but it's not impossible. It could be coming in our future.
Okay.
Um,
Well, what
yeah.
so of course the best thing is not to be subjected to the chemicals in the first place. So
Yeah.
if I start with water of unknown origin and untested water,
Mhm.
and I want to guarantee that what comes out the other end of my process is safe to drink, healthy water,
Yeah.
healthful water.
Yeah.
Water doesn't have a level of health itself,
Right.
right? So
Helpful
healthful
waters.
water.
I like that.
So what am I? What does my process look like? What does my treatment process look like?
Your process is the test. That's your process. And the reason why I say that, and I know you mentioned earlier about water changing. Water changes somewhat, but if you get a baseline, then you can put in a treatment system that accounts for changes. If that makes sense. You need
Yeah.
to find out what is competing with what in your water to be able to know whether or not your solution is the right solution. So by doing a test first and not guessing, we say that test, don't guess. You then, and when I say test, I mean a broad spectrum, like a full spectrum test. At least 50 different contaminants tested that include corrosivity levels, metals, biologics, inorganics, that kind of level of testing. Once we have that, then we can create a treatment system. And the treatment system is usually going to be some sort of ionic filtration or some sort of physical filtration. It may or may not include oxidization, depending on what's needed. And it may or may not include a point of use reverse osmosis as a backup. That's always a safe bet. So that is the way to go. If you just jump right into the deep end of the pool without testing, you're going to want to do such a large treatment train to be sure that it's going to cost you 50 grand. You have to oxidize with either ozone or chlorine, then you have to remove that with carbon. You're going to want to do nanofiltration as a pre-filtration. Before nanofiltration, you have to do step-down filtration, so you're not clogging your nanomembrane immediately.
Right.
And then you're going to want to do a whole home reverse osmosis. And then your water is going to be so clean it will just eat your pipes. So you're going to want to then add some sort of calcite back into the water in order to make it balanced. And that is fantastic water, which is probably super unnecessary.
Uh-huh.
And you've just spent 40, 50 grand on water that you could have done with a $300 test and, $2,000 or $3,000 of equipment.
I see. Okay. But if you're on the road, we
Yeah, if you're on the
we've got a
road.
trailer and it's got fire equipment in it, and we want to add some, some
Honestly,
water cleaning capabilities to it.
if you wanted to create a box, like I'm just theorizing,
Yeah, that's
if
right.
you wanted to create a box where you had a hose spigot you could run in that ran through a carbon block that was about this big, and then from there into a reverse osmosis unit with a tank to
Yep.
fill,
Yep.
that box is very doable, and that box would serve you really well. The water that comes out of that, the reason why you want the tank is because RO requires slowness.
Yes.
That's the downside of RO water, is it has to be slow. So you're going to want that water, hook in, run through. It's going to fill that tank. It's going to take like an hour or so to fill.
Yep.
You will have water from where you were just before, though, already. So you're not super worried about that. The only concerns I have with this are if you're traveling in areas where it's really hot, bacteria can build up in and a lot of exposure to various places. And the thing there that you're screwing in potentially has bacteria. You have a potential bacteria problem. So I would also want pre and post UV
Okay.
as well.
Yeah.
And that's a box you could make. It wouldn't. I mean, you'd make if you engineered that box yourself, you could probably do it for $2,000, maybe
That's
three.
a small price to pay for not drinking
Yeah,
PFAS laden microplastics.
yeah, I could help you make it, no problem. And we'd give you as close to cost as possible. We support firefighters at our company, so we have a hero discount for anyone who is our client, and for what you're doing, where you're just trying to make sure that they are safe as they're on the road. That I'd help you make those boxes for cheap.
I would love that.
Yeah,
And I think firefighters across the country would love that.
yeah, yeah. I like that idea. It's kind of a fun idea.
When they say drinking from a fire hose, they're not just being metaphorical. Like sometimes that's the water source,
Yeah,
right? And who knows what's in it.
there was a fire department near here recently who called us because they were getting when I don't know enough about this, and you can tell me, but firefighters, they do these drills where they practice putting out fires, right?
Sure.
And they have a source of water for that, which is like a giant basin of water, and it has to be because the volume of water you need.
Massive.
Yeah, massive, right? So they called us because the splash off they were getting was causing their skin to have reactions.
Wow.
So something in the water was really bad, and it turns out it was like some parasitic stuff. But
Oh goodness.
yeah, and
They're putting out fires with flesh-eating bacteria.
Yeah, it wasn't that bad. It was very minor. It all went away within like days by itself without treatment. But you wanted to get it out, so that wasn't happening. And
Right.
so yeah, the fact that firefighters are in contact with so many diverse sources of water is really an interesting consideration for sure.
Yeah. And there's certainly vapor barrier and waterproof, PPE you can wear, if you're not getting this stuff splashed all over you.
Yeah.
But still, you're deliberately drinking gallons a day.
Yeah.
Potentially from the same source.
Yeah.
You might be under the assumption that the fire hydrants are supplied by the same municipal water that creates the drinking water.
Right, which isn't always true.
Right, which might not be. And even if it is true, the drinking water might not be safe in the first place.
Yeah. I mean,
yeah.
For one time here or there, almost every municipality is going to have safe enough drinking water for like here or there. It's consistency that we're worried about with municipalities. Just, I don't want people to go away from this thinking that a municipality is itself for one-time use here or there dangerous. It's not. It's the levels that that are allowed through are so small that the single use here or there is not really a problem. But yeah, for consistency,
Yeah.
it is definitely a consideration.
Right. And you could be altering your water supply with a little bit of dangerous this here and a little bit of dangerous that there.
Right. Exactly.
Right.
Yes.
So you might not hit the permissible level on any one of them, but you
Right.
might be just under it on many of them.
Yeah,
I
that's
had a
right.
veterinarian who said, "Tell me what kind of cancer your dog has, and I'll tell you what branded dog food it's been eating."
Oh, wow.
Right. So,
Wow.
right.
That's really interesting.
Yeah. So
Yeah,
then
no,
the best solution would be, you spread it out and give a little bit of each so you don't hit the
yeah,
Pell level on any of them, right? But
that's right. I mean, 1 part per billion is the arsenic legal level. The health level is 0. And I've seen a lot of municipalities with 0.8 parts per billion. So,
okay,
like,
it's leaching out of old lawn furniture,
well,
wherever,
or
right?
it's just in the ground. I mean,
Yeah.
arsenic's on the periodic table of elements, so it can be from anywhere. If you look at the Department of Ecology map for arsenic, it'll kind of shock you.
Really? Okay.
Yeah, it's everywhere.
But no one's mapping the presence of old lace. So
That's right.
there we have it.
Also,
Interesting.
I don't want to say that firefighters using fire foam is like the big cause of this. It is a cause, but I also can't say that firefighters shouldn't have used the fire foam where they needed it, because you're not putting out an oil-based fire with water. You're just not, right? So
Right.
it's either let the fire burn everything, which is then releasing everything into the air anyhow, and then
Right. Gets back in the water, right?
back in the water. And if you add some fire foam to that, yeah, it's going to have this PFAS effect, but you didn't burn and kill people. And it's like the balancing of that seems very clear to me. So
Big
it's
trade-offs.
yeah,
Yeah, right. Well, hey, right. We've seen fire trucks that could save, hundreds of thousands of trees from burning and the houses inside those areas.
yeah,
Denied access. Maybe it's internet, folklore, but denied access to area because the emissions standard on the truck wasn't sufficient.
okay.
Like, okay, like, are we going to weigh this out? Like, emissions from the truck
That's
versus
not
emissions from the fire, huh?
okay.
It's probably more than a rumor,
Yeah,
but
that would be
it's
nuts.
pretty
I mean, that
fascinating.
would be like, yeah, I'm just going through now. Um,
Yeah. Well,
the
Cydian, if folks want to get in touch with you and get more information, what's the best way to access you?
well, we have a website, purewaternorthwest.com. I'm also very findable. I mean, my name's super unique, so if you just look me up on the internet, you'll find me.
Okay.
But you can call our company and ask for us. Yeah, or fill out a form online. Whatever you want to do. If you want to reach me, I'm reachable for sure.
Wonderful. Thank you so much. We've been chatting with Cydian Kauffman from Pure Water Northwest. You can find him at purewaternorthwest.com or any place where you Google Cydian, Cydian. It's probably going to take you right to this guy. I'm Steve
Probably.
Wolf. You've been watching and listening to The Fire Break. Hope you learned a lot about water. We're 70% water, on a good day, less on a bad day, but we should try to keep that up. But make sure that the water you're putting in you is safe. You're not poisoning yourself with that. And Cydian's information is invaluable for helping us with achieving that. We're sponsored by Team Wildfire. I was going to say the Fire Break. Well, the Fire Break is sponsored by Team Wildfire. Let me get that right. And we'll see you at the next one. Till then, be well, take care, be safe.